Alright guys, you've probably heard that the universe is expanding, and that it'll just keep going forever until it fades into cold, empty nothingness. But what if that's wrong? A new theory says that the cosmos won't die in a slow, cold whisper. It might actually snap back in on itself in a dramatic big crunch. And this is the crazy part. It might happen sooner than anyone expected. So make sure you stick around till the end to see just how this collapse could start, what it might mean for humans, and why some physicists think it's already baked into the math of the universe itself. When I was looking at my YouTube statistics, I found out that only 4% of my viewers are actually subscribed to the channel. So if you enjoy this kind of content, please do subscribe. It's literally free for you to do, and it helps me a lot. Thank you, and let's get back to the video. You're back.
I'm back.
Okay. Anyway, over the last 2 years, two major surveys, the Dark Energy Survey and the Dark Energy Spectroscopic Instrument, have been mapping millions and millions of galaxies. And finally, in their data, something weird showed up. Dark energy, which we know is the mysterious force causing the universe to expand faster and faster, itself might not be constant after all. It might be changing over time. For decades, we assumed the simplest model of the cosmological constant, which is a single number that Einstein snuck into his equations that describe the universe, and it describes dark energy. It's a fixed push, and it's a constant value. But if DES and DESI are right, that simple picture could be wrong. And that opens the door to some crazy alternative theories. A recent paper offers a pretty bold idea. I mean, what if dark energy isn't just one thing? What if it's actually two parts? One is an axion field, a hypothetical ultralight particle field that fills the entire universe. And the other is the standard cosmological constant, but this time it's negative. The axion field gives us our current expansion, but over time it dilutes. It's kind of like gas dissolving into a vacuum or something. And when that happens, the negative cosmological constant takes over, and instead of pushing the universe outward, it kind of pulls it back in. This combo means we might just be in a temporary expansion phase. Eventually, the axion field and the axions themselves lose steam, and the universe will stop expanding. Then, what happens? Boom, reversal. You take the red and you take the blue. No, I'm kidding. But gravity wins again. The reversal of the expansion, basically. The cosmos begins to shrink. Galaxies start to move towards each other, temperature and density shoots up, and it's kind of like a positive feedback loop. It keeps going over and over again. And eventually we get into a mirror image of the Big Bang, which we call a hot, dense, big crunch. And this isn't happening a Google years from now. What we really predicted was going to be the time that the universe will end. Google is an actual number. It's not just the company, obviously. It's 10 to the power of 100. So 10 with 100 zeros after it. But it's not happening that far. According to theory, collapse begins in about 10 billion years and takes about 10 billion years as well. So by about 33 billion years old, the universe will die. And that's significantly sooner than we really thought it was. So how do we actually model this? Enter the Friedmann equation. This baby governs the expansion of the universe. In this equation, alpha t is the scale factor, how stretched space is. Rho is the energy density, lambda is the cosmological constant, and k is the spatial curvature. Now if lambda is negative, the last term actually pulls expansion down instead of pushing it up. Also, cosmologists often describe dark energy with the equation of state, W, or sometimes omega. If omega is less than 1,
Bruh.
if omega is less than -1, expansion speeds up. This is the phantom energy regime. But if omega is greater than -1, it could mean expansion slows down. In this model, omega evolves with time due to the axion field, and that's the key part. Now, how solid is this theory? Let's pump the brakes a bit.
I say, hold up, wait a minute, something ain't right.
I mean, the model fits current DES and DESI data, but the data is still preliminary. And even if the constant isn't really constant, the model isn't guaranteed to be the right replacement. That said, it's a clever way to explain the observations and reintroduced the idea of a cosmic collapse. We kind of thought it was going to end up in a big rip this entire time, but maybe there's some credibility to this once old idea. So while it's still in the let's see what survives peer review phase, it is exciting. Now, what does this mean for us? If this is true, the model says we're past the halfway point of the age of the universe. The universe hit peak expansion a while ago, and the next phase is a long and slow fall. But there's not really any need to panic. We've literally got billions of years. But there's really something poetic about it. We live in a universe with a finite life that isn't just a slow fade into nothing, but technically a dramatic return to the beginning. The main point is, though, what this tells us is actually that we don't really understand dark energy as well as we thought. This is like the universe giving us a cryptic deadline. Not a really hard one. Imagine you get a billion-year deadline on your homework. I mean, we probably can do that. But it's a hint that something fundamental is still missing in physics. So what do? We keep observing. We get better telescopes, we refine our models, and we remember that everything we do, the questions we ask, the theories we build, etc., shape how future scientists will understand the end of the universe. The Friedmann equation is crucial to our idea of what general relativity is. So if you want to learn more about that, about the Friedmann equation or about general relativity, be sure to leave a comment down below and I'll definitely make a video on that. So what do you think? Do you think the universe is going to rip itself apart or collapse in on itself? Or do you think maybe there's another kind of death that you think the universe will actually have? Be sure to comment down below what you think might happen to the universe. And I hope you enjoyed this video. Thanks for watching. Keep expanding your universe, guys. Or, I guess, what if the universe stops expanding? That's far enough. Keep expanding your universe, guys, and see you next time.
Don't forget to like and subscribe. It's free, and you can change your mind at any point in time, and it really helps me out as well.